Hello everyone, my name's Dr. Vile. Welcome to my YouTube channel for A-Level Chemistry. If you find these videos helpful, please like, please subscribe, please keep checking back for more content which will be added regularly. And the purpose of this video is going to be looking at how we determine what the empirical formula is for a substance. And like with many things, it's best looked at with examples, but we do need to understand what we mean by an empirical formula first. An empirical formula is simply the simplest ratio of the atoms. So it's not necessarily the same as the molecular formula, which is the exact number of atoms, but in this case it is the simplest ratio of the atoms. So for instance, if the molecular formula was C4H10, to work out the empirical formula, we could divide both of these numbers by 2. And that would give you C2H5. So that would be the empirical formula, and that would be the molecular formula there. If I had C6H6, you could divide both by 6, and then the empirical formula would be CH. But if I had, let me think of an example. If I had C3H8 as the molecular formula, the empirical formula would also be C3H8. You can't simplify C3H8 any further. Right, let's look at some actual problems. You may want to pause the video and have a go at each one before I go through it. That might be a helpful way to do things, but that's up to you. So it firstly says a hydrocarbon is found to contain 4.8 grams of carbon and 1 gram of hydrogen. Calculate its empirical formula. So what you do is you divide each of these masses by the atomic mass. So you do, for the carbon, you do 4.8 and you divide it by 12. And for the hydrogen, you do 1.0 divided by 1. So when you do the calculations, for carbon it comes out as 0.4 and for hydrogen it comes out as 1.0. Now what you need to do is divide both of these numbers by the smallest number. So you divide them both by 0.4. So 0.4 divided by 0.4 equals 1. And 1 divided by 0.4 is 2.5. So the ratio is 1 to 2.5, but you can't have that as your answer because you can't have a whole number in the empirical formula. So you can't have a decimal in the empirical formula. So what we then do is times both of these by 2. So that gives us C2H5 as the answer. And that is the answer. That is the empirical formula. Let's look at another example. You may want to pause and have a go at it first. What is the empirical formula for a compound containing 40% sulfur, 60% oxygen by mass? So you start with the sulfur and you do 40 divided by 32.1, which is just the atomic mass of the sulfur. And for the oxygen, you would do 60 divided by 16. So when you put both of those into your calculator, you come up with 1.25 to 3.75. Divide them both by the smallest, and you'd end up with a ratio of 1 to 3. So therefore your empirical formula must be SO3. 1 sulfur for every 3 oxygens. And then lastly for this video, what is the empirical formula for a compound containing 38.8% carbon, 16.2% hydrogen, and 45.1% nitrogen? Okay, so you do the carbon in one column, 38.8 divided by 12. For the hydrogen, 16.2 divided by 1. And for the nitrogen, 45.1 divided by 14. So when you chuck all of those into your calculator, for carbon you get 3.23, for hydrogen you get 16.2, and for nitrogen you get 3.22. Now for the purposes of this, we can assume that these for the carbon and the nitrogen are the same. Divide them all by the smallest number, and what this gives you is 1 to 5 to 1. So that would be CH5N. So 1 carbon to 5 hydrogens to 1 nitrogen. Anyway, I hope that was helpful. Just a very short whirlwind tour of how to do the formula. If you found this video helpful, please like, please subscribe, and please share, and please keep checking back. Thanks everyone.